Guys, glad you have you here. So in this talk, we're going to talk about migrating the Spinnaker operator to Glit and why we're going to do it. As you can see in the image, we're a talented group of engineers that we work in the platform UX team in Armory. So we are Todd Underwood, is our technical lead and senior software engineer. We work with Christian Castañeda, that is our senior software engineer. Fernando Freire, that is our principal software engineer. And my full name, yeah, that's my full name, Alfonso Alejandro Espinosa Los Monteros Andrade. And I'm a front-end engineer learning how to do this. I'm going to give you more context about Armory. So we were founded in 2016 to unlock innovation by making software delivery continuous, collaborative, scalable, and safe. So Armory works hand by hand with Spinnaker at its core. So in the next slide, we're going to talk about more about operator.
Hello, guys. This is Christian, and I will talk about what an operator is and how it relates to Spinnaker. So operators, in a nutshell, are software extensions to Kubernetes that make use of customer resources or CRDs to manage applications and their components. And yeah, probably you're thinking how it relates with Spinnaker, right? Well, at Armory, we have created the Spinnaker operator to deploy and manage Spinnaker in a much easier way. This project basically is following the Kubernetes operator patterns, and we have created the Spinnaker service CRD that basically contains all the configurations that Spinnaker needs. The Spinnaker service CRD is an exact representation of what a HAL config is. You only need to do some adaptations to the configurations, and you will be able to deploy a Spinnaker instance. The project is written in Go, and we are using the operator SDK project to create the custom resource definition.
So we're going to do a live demo about how to install Spinnaker operator in your local machine. For the purpose of this demo, I already created a cluster with kind and created and downloaded the latest operator in my local machine. So from now, if you see, I'm going to start copying these commands from our Armory docs that I already have the resources page in the last of our presentation. So also I have an alias in my computer. Instead of typing kubectl, I'm going to type kc, and then I'm going to pass the context that I already created up here. So for now, I'm going to do this. And apply the CRDs. Good. So now they're created. Once the CRDs are created, we need to create the Spinnaker operator namespace. And then I'm just going to copy this. And then create operator namespace. So everything's successful. So we're in a good track here. Now I'm going to install operator, deploying the cluster. Again, sorry for the long typing here, but it is what it is. Now from here, we've created the cluster. So now we can get the pods from this namespace that we already created. Let me just delete this guy. And then we are waiting only for the containers to be created. If you already have watch install, we can see what's happening here. And it's running. Once this finishes, we have to create a Spinnaker namespace to enable to have a different namespace from operator and our Spinnaker cluster. Now, once our Spinnaker operator is ready, we can create our namespace for Spinnaker itself. So kc -context, demo test. I don't know what is this. Create namespace Spinnaker, and then we're going to call it a Spinnaker. Good, it's created. Now, from now on, we're going to go to Armory GitHub, and then we're going to find these Spinnaker patches. So we can't just launch Spinnaker in our local machine. So we're going to attach this link, of course, at the end. And then if you can see here, we have two API versions, the Armory itself and the OSS itself. So I'm going to show you where we need to change this behavior in code. So from now, we're going to jump here. If you go to the Spinnaker service YAML, you see that here that I already did the changes. Also, we're pulling the latest version in Spinnaker itself. So if you're curious about those versions, you can just jump here and see the change log. Then we're going to find all the .armory.ios and replace it with a Spinnaker, as you can see here. Also in Spinnaker, there is one. And in patch menu, there is another one. If you're curious where I got this one, where I found it, you can go to customization YAML, and then you have to check all these files from here to make sure it will work. So now we're in a good track. I have to change the context in my local machine to just run the secrets. We require to run the Spinnaker. So let me just change the context, and then now we have this useful bash here to create the secrets. So you have to be positioning right to find this folder. So now we're going to create the secrets that we need to launch Spinnaker in the local machine that we need here. So we have this useful bash in create secrets. So you have to run it and passing the namespace we previously created. Once our secrets are done, we're going to apply these changes with customize. So now we're here in our customized patches, and we're going to apply the changes to the namespace we already created. Now that they're all created, we can just watch the pods to see what's happening. We can just watch. Change the namespace here, and then let's watch the pods to see what's happening. This operation might take some minutes depending on your local setup, so we can see what's happening here. After having to wait 14 on my side, all the services are up and running and healthy. So now what we're going to do is just port forward gate and deck. That is all we need to see Spinnaker live. So when we port forward gate, don't forget about posting the right port, that is 8084. And now we're going to do deck, that is on port 9000. And if everything goes well, we can see Spinnaker up and running in our machine. There we go. And now you have your own Spinnaker cluster up and running. Thank you, guys.
Thank you, Alejandro, for that demo. Hi, everyone. My name is Todd Underwood. I'm the technical lead for the platform user experience team here at Armory, and we're the team that primarily maintains the Spinnaker operator. So why are we here? Why are we talking about this? The long story short is that in January of 2020, the Spinnaker Technical Oversight Committee accepted RFC 89, which calls for the replacement of Halyard as the recommended solution for deploying Spinnaker. The Spinnaker operator relies on Halyard running in a sidecar in order to generate configurations and manifests that deploy the platform. So we need to see about removing Halyard and replacing it with something. What's the solution? The answer is Cleat. Cleat's a lightweight library written in Go that can generate Spinnaker configuration files from halconfigs. Unlike Halyard, it can be embedded directly into the operator so that we don't have to have it running in a sidecar, which is going to make maintaining the operator easier for teams like us, and it's going to make debugging issues easier for teams that use it. In short, we need to refactor the operator to replace Halyard with Cleat. So how are we going to do that? To answer that, let's look at what the current implementation looks like. Currently, if you have the operator running in your cluster, you give a Spinnaker service manifest, you apply that to your cluster, and we go through a number of steps. The first thing that happens is the operator attempts to validate your configuration. Some of that is done natively in the operator, but other things are done in Halyard in the sidecar. So the operator needs to make a series of calls from the operator to the Halyard sidecar that's running on the pod. This is for things like security, cloud providers, persistent storage, canary configurations, and a few other things. After you validated everything, we then generate the manifests. This again requires a call out to the Halyard sidecar. We pass the HAL config out to Halyard sidecar. The microservices configurations are generated. This is things like your cloud driver.yml, your fiat.yml files, etc. Those are then processed by Halyard to generate Kubernetes manifests, which are then returned back to the operator. At that point, the operator has a series of transformations that it may pass those manifests through, and then the operator deploys the manifests. We then repeat that following the general control cycle of checking the desired state versus the current state, and until we get an update, we keep things running. So what does it potentially look like if we were to remove Halyard altogether? So you can see the operator gets a little bit bigger. We still pass in a Spinnaker service YAML file, but this time we don't have a sidecar running. So at this point, we need to get the services, the service versions for the Spinnaker version you're trying to run. So if you're running Spinnaker 1.26, that needs to map to cloud driver version, 1.26.2 or whatever it might be. This needs to be done via some kind of a bill of materials like method or something like that. We need to figure out what that looks like. Then we need to do the validations. Previously, this was done in Halyard. So we need to migrate that work into the operator. Then we need to move into generating the configurations for all the Spinnaker subservices. This is something that the Cleat library is directly able to handle. And so we can pass the HAL config from the operator code into the Cleat library running in the operator. And then that will return all of our various Spinnaker service configuration files. And this is where things really change. In the Halyard version of the operator, we've relied on Halyard to generate our Kubernetes manifests. In a Cleat version, we're not going to rely on Cleat to do that generation. Instead, what we would do is look at the customization base templates that the Spinnaker community has provided. They're located in GitHub. And that allows us to take our Cleat generated manifests or configurations, pass them into customize alongside these community provided manifests and templates, and that can generate our Spinnaker Kubernetes manifests using customize. We want to find a way that we're not necessarily reliant on being able to talk to GitHub to pull those down in real time. So we'll need to look at how that works. But this is kind of the plan for the community going forward on how to set up Spinnaker. Once you have those manifests, we go through the same transformations that we did in the Halyard version and then move on to deploy. So now looking at where things are and where things could be going, what do we have to do to get this done? Well, we've identified 3 kind of milestones that need to be done to get this implemented in the Spinnaker operator. The first thing is to migrate those validators from Halyard, which is written in Java, to the Spinnaker operator written in Golang. This is a pretty easy lift and shift, but there's going to be some language translation that needs to happen for the logic to function properly. After that, we need to migrate the Spinnaker service configuration from Halyard to Cleat. We want this to be done in a backwards compatible method so that you can still take the same HAL config you were passing to the Halyard sidecar before, and this time pass it into the Cleat library. We don't want teams to have to go through and modify that HAL config manually. We want it to be as backwards compatible and as low effort to migrate as possible. And then lastly, we need to migrate the generation of the actual Kubernetes manifests from Halyard to using the new customized base repository that the Spinnaker community has provided. So with these 3 things, we can completely remove Halyard and replace it with Cleat and maintain full backwards compatibility to the current operator. So why are we having this conversation? What does this mean for you? In short, we would love to have collaboration with other organizations in order to help get this implemented. We always welcome PRs to the Spinnaker operator, and we'd love to help you get involved. If you have questions or would like to contribute, you can find all of us on GitHub and on the Spinnaker Slack team. You can find me personally at T Underwood on GitHub and at Todd Underwood on the Spinnaker Slack team. And the rest of the team has their contact information here. If you're interested in contributing to this effort, don't hesitate to reach out. We're happy to help get you started and to help plan the roadmap and things like that if you want to be involved. So with that, I'm sure we have some questions that you might want to ask, and we're happy to answer them, but that's what we have for this content right now. So thank you very much, and we're looking forward to your PRs.
Todd, I think you might be muted.
Okay, sorry about that. Hopefully everyone can hear me now. We're having some technical issues today, so apologies for that. Hi everyone, my name's Todd Underwood. As you heard in the video, I'm the technical lead here for Armory. And so if you guys have questions, Fernando and I are here to take them and are happy to answer them. So it looks like we might have one person in the queue right now, so we'll go ahead and pull up Anish. I'm gonna see how this works. Maybe. If there are any questions, feel free to put them in the Q&A as well. So at this point, we've ended the the pre-recorded radio content we had for this talk. If you guys have any questions about contributing to the operator or about converting it from Halyard into more of a Go native implementation with Cleat, feel free to ask. Fernando and I are here to answer questions for the next 10 minutes or so. Otherwise, that's all the content we've got. So.
Yeah, I'm just checking the Q&A section here, and I don't see any questions so far. So feel free to put them in the chat or in the Q&A section. So it looks like we have a question from Thomas. Todd, do you want to take a stab at it, or would you like me to?
How about you take this one, Fernando?
Sure. So can you speak a little bit more to what you're interested in the customized learning curve? I mean, I can talk about it in aggregate, but I can provide a better answer if I know exactly what you're looking for. I guess the general case is that Kustomize is a tool similar to Helm, right, where it allows you to templatize a lot of the manifests that you have. Kustomize provides a little bit less of the like structured packaging that Helm does, and Kustomize allows you to do more of that like targeted changes that you want to make to just specific parts of a particular manifest. I would say the learning curve is pretty similar, I would say. But yeah, we can dig into more of that if you have a different area that you want to dig into, Thomas.
So Thomas, for that one, it probably depends a little bit how familiar you are with Kubernetes and things like that. But I can say I probably picked up the basics of Kustomize in just a couple of days. It's not a terribly complicated thing to pick up once you learn the basic patterns. So I would say that once you get kind of that basic pattern stuff, you can take off pretty quick.
Of course, there's that plateau of learning, right? Once you cross it and you kind of understand things. And I think the biggest hurdle for me was understanding the resolution system that Kustomize has, right? It's like when you have your main file and you're declaring like the API version, kind, and name, and then you're creating patch files and you're wondering like how those patch files get resolved to that main manifest. I think that was the biggest challenge for me. But once I understood that, the rest is pretty straightforward. We have one question from Jay in the Q&A section. Does the Cleat part make BOM management easier? So I can take that if you're interested, Todd. So there is less of a concept of a BOM when you move to Cleat. So what Cleat does is it takes, right? And you can see examples of that in the in the Cleat repo. It links to like a base customization repository. And that's actually where all of the images are going to be declared from this point going forward. So there isn't going to be a BOM that's going to live in like a Halyard bucket somewhere that you're going to pull down, right? So you'll be able to do a lot more customization. Well, pun not very much not intended, but you can do a lot more customization with the kinds of images that you're sending out. And it'll say, I only want to deploy this version of the image over the other. And I know as part of the release process revamp that some of our colleagues are doing. I can't recall what SIG exactly it is, but I know we're planning on revamping how a lot of these containers get built and published. And I think that'll change as well as we get closer to the resolution of that work. Okay, we have another question from Marlon. Do you think Cleat will make air-gap installs more frictionless? Yeah, I think by definition of not requiring a BOM file, I think that's one of the largest issues with doing an air-gapped install today, where you kind of have to recreate the environment where that BOM file lives in order for Halyard to be able to pull it. So, with that base customization directory now, and then any patches that you want to apply on top of that, I think it'll be a little bit more straightforward for you to install in an air-gapped environment.
So we have another question. So in this case, we use the Armory operator. It's a kind of smooth. One question I have is, are there any plugins available to access Vault secrets during the execution of the pipeline? Kind of a sidecar for Vault for the K8s job or pod.
Yeah, to my knowledge, this is available in the Armory operator, and it's not available in the open source operator. So if you're interested in taking advantage of that functionality, feel free to reach out to your account manager and they can point you in the right direction. And we have another question from Jamie. Does Cleat support revert generated manifest back to HAL config? So if I'm understanding the question correctly, I'll rephrase it here, but I believe what you're asking is if Cleat can generate a HAL config for you to go back to Halyard if you choose. And I don't believe that's possible, right? So the migration path is mostly going to be mechanical changes going from your HAL config to an equivalent customized base, and then the Spinnaker service manifest that you'd be using to install. I think that's a different question, Jay. So if the question is, does Cleat make managing vault secrets in the pipeline easier rather than the tool itself? I don't think it makes it any easier or harder than it was under Halyard. You're going to run into the same issues that you were before. Cleat is really just one half of the Halyard equation, right? It's really just generating the configuration that you're going to put on the pods. It's not going to resolve any of the secrets that you're trying to put into your what was the HAL config, right? So any secret resolution is going to happen in the operator itself.
Okay, well, we have about a minute and a half left or so. So if there's any further questions, we're happy to take them. Otherwise, thank you guys all for coming out and watching the talk. And feel free to reach out to us if you have any questions about Operator or getting it converted over to Cleat. And enjoy the rest of the Spinnaker Summit today and the rest of the CDCon.